Good day, sir. I am Jin Nodalo from Bismarck E3 Delta. So today we will talk about a steam turbine. So first, what is a steam turbine? So a steam turbine, it is a device that extracts thermal energy from the pressurized steam and uses it to do mechanical work on a rotating output shaft that used for very large proportion or for a very large main proportion power, just like we have seen in the ship. So there are two types of turbine being used in the steam turbine. So which is the impulse and the reaction type turbine. So in the impulse turbine, its arrangement is made up of ring of nozzle followed by a ring of blades. So when the high pressure and high energy steam is expanded in the nozzle, it becomes it becomes a lower pressure and high velocity jet of steam. So those jet of steam or high velocity jet of steam is directed to the impulse blade and leaves in the opposite direction. So those change in velocity and direction would create or would produce an impulsive force which mainly acts on the direction of the rotation of the turbine blade. So next, we will discuss about the reaction type turbine. So the reaction type turbine, its arrangement is made of a ring of fixed blade attached to the casing and a row of similar blades similar blades mounted on the rotor. So the blades that are mounted or the arrangement of this reaction type would create a narrow passage. So those narrow passage would increase the steam velocity. So those change in velocity or increase in velocity over sa blade would produce a reaction force. So those reaction force is directed to the rotation of the turbine axis. So once there are change of velocity, we will assume that there are also a change of direction. So those change of direction would create an impulsive force. So there are impulsive force being created, so resulting in those change in direction. So the correct term for this reaction type is also known as the impulse reaction type of turbine. So now we are done with the two types of turbine. So next we will go to the compounding. So first, we must talk about what is compounding itself. So the compounding is splitting up into two or more stages of the steam pressure, in which the energy of the steam is extracted in a number of stages rather than a single stage of a turbine. So there are two types of compounding being introduced or being asked in this topic. So which is the pressure compounding and the velocity compounding of an impulse turbine. So in the pressure compounding of an impulse turbine, it uses a number of stages of nozzle and blade para ma-reduce progressively ang iyang steam pressure. That would result in an acceptable steam speed flow and would result in a better turbine efficiency. So now we'll talk again to the velocity compounding next. So velocity compounding, so it uses a single nozzle with several moving blades. So between those moving blades, there are fitted guide shoes. So those guide shoes are connected to the turbine casing. So those arrangement would create a short lightweight of the turbine that would result to the poorer efficiency or would lead to a poorer efficiency of the turbine. So next we will proceed to the operating procedure of our steam turbine. First we will talk about the warming up our steam turbine. So in warming up the steam turbine, so first we must open all the valves that are necessary in warming up, like turbine casing, drain valves, all blades, steam drain valves, and we must ensure that the steam control valves and the maneuvering station and also the turbine are closed, or around the turbine are being closed. So start the lubricating oil pump, then obtain clearance sa ato ang bridge to turn the shaft. And also we must engage the turning gear and rotate the turbine in each direction. So after that, we must start the seawater circulating pump and open the maneuvering valve bypass, or the warming through valve. So we must ensure also that the turbine temperature in the warming up our steam turbine should be about 75 degrees Celsius, 75 degrees Celsius. So, and also the expansion movement should be checked. So we must check also the expansion movement in warming up our steam turbine. So the turning gear, after we check all the necessary things, so the turning gear should now be disengaged. So after disengage, a short blast of steam are now admitted to the turbine to spin the propeller about one revolution. So it should be repeated about 3 to 5 minutes for a period of 15 to 30 minutes. So the turbines, so after that we must operate. So the turbines are now ready for use. So while because this process will take up long, so while waiting the turbine, we must be turned ahead once every 5 minutes by the steam blast. So since this operation is very long, or it takes time, so it must turn ahead once every 5 minutes by a steam blast. So now that we are done in warming up, so next we will proceed to maneuvering. So once we are warmed through, or we are done warming up our steam turbine, so the turbine rotor must remain stationary for more than a few minutes to prevent the rotor from sag or distort that may lead failure sa ato ang turbine. Then after that, after an operation, admit a steam. So this after operation admits steam to our Astern turbine. And also when operating the Astern operation, we must monitor or closely observe the turbine temperature, turbine noise level, and any abnormalities that are present in the operation of Astern. So the turbine manufacturer may set a limit also of about, I think, 30 minutes on a continuous running of our Astern operation. Excuse me. So next is the emergency Astern operation. So when traveling at full speed, an order for an emergency stop must or the Astern movement is required, but the safe operating procedure, we must ignore it, or we must ignore it. So a head stem is shut off by the use of emergency trip, and the Astern steam valve must be open to admit the gradually increasing of steam, or gradually increasing sa amount sa ato ang steam. So the turbine can now be stopped, but this stopping of our turbine would take up, I think, mga 10 to 15 minutes before a similar state will occur for the ship. So the use, because di ba ganina wala ta use atong emergency procedure, kay kaning emergency procedure man god in our emergency Astern operation could lead serious damage in the turbine or even the boiler. So now we are done with the emergency Astern operation. So next we will discuss about full away. So in this full away maneuvering revolution is usually about 80% of full away or full speed. So once there are command is being received or full away command is received, then the turbine can gradually lang ang pag-brought up sa full power sa ato ang operation. So this process will take up long for more than about I think 1 to 2 hours, because this process would take time. So this also involves turning on our or use our turbo alternators, which uses a steam remove at some stages of the main turbine. So after that we must check the expansion arrangement and close all the drains, condensator, circulation valve, and also the astern steam valve must be tightly closed. So next, we will discuss about port arrival. So prior sa arriving at the port, so prior ganito arriving at the port, so the bridge ganit. So the bridge should provide 1 to 2 hours notice para or to enables the turbine to be brought down into maneuvering revolution. So ang ato ang diesel alternators must be shut down diesel alternators must be started and the turbo alternators must be shut down, and all the full away procedure must be done in reverse order or reversely done.